Okay, so number 55 here, read the question. So this waiter has taken stats before. He thinks that his tip distribution is slightly skewed to the right. His average tip for his population is $9.60, standard deviation of 540. Part A, why can we not determine the probability that his next tip is at least $20? And if we were in the classroom, if this were face-to-face, I would wait for 10 minutes while you guys throw out a whole bunch of reasons why you can't make predictions here. And you would say a whole bunch of stuff that's wrong. And then finally I would say, no, no, no. It's because we don't know his distribution. I don't have a button on my calculator that says waiter tip. If I did, I could make predictions about what the next tip would be. If we look at the calculator, under distributions, there's no waiter tip button. We've been using number 2, normal distributions. I can't use that one in this problem because he's not normal. He's slightly skewed. If that said normal, then I could make predictions about individuals. I would use the normal model, but I don't know what model to use because we don't have that button on our calculator. That's why we can't do it. It's not because, well, you never know what the next person's, of course you don't know what the next person's going to do, but you can still make predictions. You can give probabilities. Now, part B, can we estimate something about the next 4 if we have a sample of size 4? That's kind of small. I don't know. We say here slightly skewed to the right. I know I can't make predictions about samples of 1. 4 is kind of small still. I don't know how slightly is slightly skewed. That's the point of this question, is to get us to think about our sample size. If it's just barely skewed, if it's almost normal, then yeah, we could probably make predictions about size 4. Question C says, well, now let's move it up. Let's move our sample size to 10. Now let's make predictions. Well, okay, since we're only slightly skewed, 10 is probably a big enough sample size. The closer to normal we are, the smaller the sample we can use. And I wish there were like hard and fast rules that I could teach you and say, well, if it says this, then this N is good enough, but there really aren't. It's always a, well, you run the numbers and then you check and see, is your answer reasonable kind of game. Okay, so let's do this problem. Let's do part C. So the first thing we're going to write down is let mu be the mean tip this waiter gets. He thinks it's 960 with a standard deviation, sigma of 540. Now we're going to look at a sample of size 10, and I want to know the probability that his average is more than $15. So I identified my variable. I want the probability that the average of the next 10, not the next person could be all over the place, but the average of the next 10 is more than $15. Let me draw a picture. Right in the middle is the population average, 960. I want to be 15 and above. We find our z-score. Oh, we need to find our standard deviation, sigma divided by square root of n. So 540 divided by square root of 10. Oh, get out of there. 540 divided by Square root of 10. 1.771. So our z-score is going to be the one we want minus the one in the middle divided by that standard deviation we just found. (15 minus 960 divided by 1.71). That is 3.16 standard deviations above the mean. That would be really weird. That would be a weird sample. That's a giant z-score. Then we want to do normal CDF. We shaded from there and above, so the smallest to the largest. So what was it? 3.16 to 99. And we get, here, let me share the screen. I want you to see this. There's a reason I wanted to do this problem. We get this answer. That is not 700%. You will never get an answer from normal CDF bigger than 1. That is 7.9 times 10 to the negative 4th. That is an incredibly small number. You have to be on the lookout for that scientific notation. If this is ever bigger than 1, it's scientific notation. So what does that mean in terms of this problem? It means it's very, very unlikely that if the next 10 parties come in, and we're not saying one person gives him a tip of 15, all of them give him a tip of 15 or more, or the average at least is 15 or more. He's used to getting 960. He gets 10 parties in a row that give him big tips. Either this sample doesn't look like the rest of the population. Maybe something's going on today. Maybe there was a big giant museum gala event and a whole bunch of high rollers came into town. People that tip really big. And that sample just doesn't look like the rest of his population. Or maybe he was just wrong to begin with. Maybe his average was never 960. Maybe it's always been higher and he just messed up.